Hello everyone, welcome to the Game Engineering Podcast. Today I am joined by Tomislav, level designer, environmental artist, or as he liked to call himself, technical content designer from Croteam, so the makers of Serious Sam games and Talos Principle. And I must say I absolutely adore Talos Principle. It was such an honor to host Tomislav and discuss with him all the details that went into making beautiful Talos Principle 2 scenes. We discussed pretty much everything that goes into making terrain, like landscape, foliage, so all the grass blades, tiny rocks, larger rocks, trees, but also water surfaces from looking from above, but also from below, under the water, things like sky, light, how light changes. We discussed this in the context of Unreal, so the engine where Talos Principle 2 was made. So we also discuss Lumen and Nanite, how these technologies work. It's a very technical episode. I loved it. I hope you love it too. Then tell me, who are you? What was your role on Talos Principle 2 then?
Okay, so my name is Tomislav, and I started working at Croteam like 8 years ago. Been working on the Talos on the Serious Sam: The Last Hope, the VR title, Serious Sam 4, and now for the past 3 years, Talos Principle 2. On Talos, I was primarily a level artist and technical artist. Later, I also branched into lighting art, and I generally call myself a technical content designer since I also deal with optimizations, content optimization, since I have a fairly deep knowledge of especially new Unreal Engine technologies like Nanite, Lumen, Virtual Shadow Mask, Row Partition, and similar. Like,
Technical content designer.
yeah, technical content designer. You don't really see that everywhere. I think I've seen that like in only Epic like job positions, like technical content designer. It's like a merge between technical and content, I would say, domains.
Okay. And, okay. So level artist, you're saying that you worked on the environment and levels on Talos Principle too. So both the areas of the puzzles and outside, or
Okay, so my part was generally as a level artist, I started working on like world layout. We're starting with landscapes and determining where to place the puzzles themselves. And I also had a huge work done on, I would say, biome slash vegetation setup from procedural foliage, landscape grass system, and sometimes painted foliage. But definitely, I made the foliage. I did the foliage technically in a sense of I determined how to set up the foliage types, landscape grass types, how to actually have it optimized throughout the game. And later, some other level artists did the finalized work. I don't think you can see anything like everything like finally in the game is not really my work in a sense of labor that I like decorated some levels or something like that. It's just I made the base so everybody else can do it.
okay. So how does this work? Like, where do you where do you start from, and what is kind of your task? You're told, for example, create a world, and you're up to you need to decide how this will look like, or uh, do you need what kind of constraints do you have for this?
Well, for every world, for every like level, uh, we had a vision. Our game director had a vision for, okay, I want this to be like this type of a biome, like let's say for uh, east east clusters. We we wanted to have it like a lush green meadow, like European, like meadow biome, like all greenery. Nothing, not like a jungle or something like that, but just your ordinary green meadows, I would say. And then I would work in those kinds of constraints, whereas I would look at some real world references, how it might look, what vegetation can we actually get through, like from the store itself, because as we are a small team, we don't most of those stuff like vegetation, foliage, ground clutter is a bought asset that we later process a lot so we can actually make it game ready because well I don't think there's no asset pack that's game ready from this from the start from the point when you buy it. You still need to tweak it a lot, so pretty much it's not an asset flip. So and from there you just start experimenting with like your procedural systems. Maybe lately for our other projects, for our next projects that we are doing, I started prototyping the setup with painting, like manual foliage painting with the foliage tool. Unreal has a really cool foliage tool where you can manually paint multiple foliage types, foliage instances. And with that, it was a faster prototyping phase for like, okay, I want this type of look for the procedural, and then you just tweak the numbers on the procedurals.
Okay. And before we get into more details, maybe it's worth noting how many people have worked on Talos Principle 2 and what were their roles?
I don't know exact numbers. I hate this. Around 40 people. Around 40 people. And when it comes to like level artists slash artists, there was a lot, maybe 12 to 15, something like that. We had people in and out, like maybe 2 or 3 people in and out during the project itself. But generally, we stayed a the core team stayed the same pretty much.
Okay. And so that's, I mean, that's both a lot and it's small number in general, but for the sharing files through Unreal, it's quite a big number. Did you have like how does it look like in Unreal to have conflicts for the files and things like that?
And that's an interesting thing. We started working on Unreal Engine 4 like more than 3 years ago when that was like 20. That was 2020. Yeah, just as the pandemic was going on, we started working on Talos 2 on Unreal Engine 4.25, and then went to 2.6 and 27, and then Unreal Engine 5 came out. We didn't immediately jump. I can't remember exactly how much time passed since the UE5 release and when we migrated to it. But when we migrated to it, we heavily utilized the one file per actor system that helped us a lot when it comes to conflict. We didn't have any conflict at that point when it comes to level art and level design. So one file per actor, for those who don't know, is a new system that works exclusively with world partition levels, and world partition is a streaming system. I can talk about that later. Uh, but it only works with that type of level where each like actor, each instance, each like model you put in a level will generate one file on the source control.
Oh, okay.
So you will like move a fence, a rock, or like a puzzle wall or whatever. It's only that file that will be checked out, and everything else is like as is on the server. It does come with a caveat that you will have a lot of files. Like we had in the end, we had like up to around 500,000 files for Talos 2 at the end of the dev. 500,000 files.
In bytes, how much was this?
I have no idea. In tens of gigabytes, I think. I mean, it's the size still I think stays the same. Like you say, you use a UMAP file, that's a level file for Unreal, and you like convert it to a one file per actor level, let's say. The size stays the same. One thing that really uh, was a real hurdle was when you open a level, you open the project itself, the Unreal Engine editor itself, uh, it parses through all the files, and that took a couple more, like 10 seconds or 15 seconds to do, so it can actually go through all the files on the content browser. So that was a like, okay, we'll we'll get through this, but this is a real pain to wait every time like 10, 15 seconds to for all the files to be parsed until you can actually use the editor itself.
But this was the only time for in startup, like full startup of your project in Unreal took in seconds, not minutes. I would expect it would be even longer, right?
Well, it depends on your computer. We have a fairly strong computers here, so yeah. Before you would just open the level and you will have wait like 2 3 seconds until everything came up, or you had some new shaders that needed to be compiled, maybe a bit more seconds to wait. But now every single time you open the level, you need to wait at least 10 50 seconds for those files to be parsed, and the engine is frozen during that time. So you better not do anything.
Okay. Okay. So I'd like to ask you, like when I'm in Talos Principle, I'm playing Talos Principle 2, and I'm in a level, what I see, what components I see that make up the scene. So, you know, from the, like, it's very easy to miss when things look right and when things look beautiful. You don't understand how many components go into the scene.
Oh boy. Well, each each level would have from 7 to 8,000 to sometimes even 15,000 actors, and that mean an actor is a kind of a weird sentence because sometimes for us the foliage itself is a couple of actors because they are instanced, whereas you have a lot of geometry, a lot of meshes that are like singleton actors, I would say. But when it comes to the higher level, like what makes up a level, like the first things you might see is the landscape where you're standing on, the foliage itself, which are a couple of, due to it being row partition, it's like in a grid system. So each grid gets its own foliage actor, which is an instance mesh actor. So it's a lot more optimal, and that Unreal takes care of that by itself. So you don't really have to have a special setup for it. Then you would see other stuff like VFX, atmospherics for like the sun, the atmosphere, the sky dome, uh, and then as you go on, you would see the mechanics, the gameplay mechanics for the puzzle meshes. And then there are a lot of other actors. There are like scripts, splines, level scenes for like cutscenes or for like conversation or dialogue. There's a lot of that goes in the background that even I am not really sure what's going on there. Yeah. I'm just aware that it's there.
Yeah. To be precise, to be very clear on the terminology, when you're saying landscape, you mean the terrain, right?
Yes, landscape. Yeah, generally the landscape, its material, and Qt with something we call, well, Unreal Engine calls landscape grass, which is a which you determine inside the material for landscape on which layer which type of foliage will spawn. But that's different than like foliage. You have foliage and then landscape grass. It's a separate system, but can work together.
Okay. And when you say foliage, you mean both the grass and small rocks that are being put on the terrain to make it more like realistic.
Yeah.
Okay. Okay. And when you say actor, just to be like super precise, you mean pretty much anything, because that's the Unreal terminology. It's a different one from, for example,
Yeah.
Unity's, right?
Yeah, for Unity, it's an entity, I think.
I think it's game object.
Game object, yeah. In Serious Engine, we had entity. Like every like every class or every like object you put in a level that you can like transform, move, tweak its details, is an actor. For example, you can have one actor that's like a foliage instance foliage actor, but it's in its side. It can have thousands of instances, but it's still one actor by itself.
Okay. So you're tasked, let's say, to create a world, let's say from the east part. So similar to, let's say, what you could find in a like raw European outside of the city place, and you need to both do the landscape, the terrain, and the foliage. In terms of the terrain sculpting, how do you do that?
We ended up doing like manual sculpting because it was the easiest. And our levels weren't so big that we needed like a world machine type or a Gaia type generation for height maps. We started doing that, but just it took a lot of control, and the levels are just too much like authored for it to be useful. It would just be a hurdle by itself. We did use specifically Gaia for generating background landscapes, where we generate the height maps and then just export it as a mesh and use the masks inside a specialized material that then was put on those background landscapes.
Okay. Gaia is a standalone thing, or is it plugins? Okay.
Gaia is a standalone like landscape generation software.
Okay. Okay. You hand sculpted the entire every level in the game? This is a lot of work.
Yeah. Well, 3 years. It took us 3 years, so yeah.
And you're mentioning that your levels are not that big. So then, if you play Talos Principle, they feel big.
Well, they were bigger. I would say that they were bigger. We had a problem in testing that during testing that a lot of our levers were like too big, in a sense like there was a too the distance was too far between two puzzles. There was just a lot of walking and not much of type of exploration at the time. There was not much there's not much use to exploring. It was just an empty world with like pretty flowers. And we did size them down. Well, other level authors sized them down, and it. I think the biggest level is East 3. I think that's the biggest level, and that was like at least 50% bigger before.
Nice. And just to make it clear, right? You have 12. You have 12 worlds, like 12 levels that you talk about. But then you have the middle. And yeah, for everybody who's listening, there will be probably spoilers here for the for the story and things like that. So now I'm gonna proceed to one. But in the middle, you have the mega structure, and also you have the levels inside them, right? So when you're saying East 3, you mean one of the 12 levels that surround some mega structure. Yeah.
So the structure itself was like you would have that central pyramid hub from where you would go to like 4 sides of the world, and each side of the world would contain 3 levels that we call clusters. So each side of the world will have 3 clusters, and you would get 12 clusters in that list from that.
So you're making the east level. You're sculpting. You sculpt the terrain, right? And now
So first you would start with the overall like what kind of a level would it be? Would it be like an island? Would it be like an how do you call it, a delta between two areas? Because we need to think about how do we limit the player, because you can't have the player like walk around, and we really wanted to avoid like invisible walls or like kill zones. So unless it's like a logical kill zone, for us it was water. If you go into the water, you'll just get sent back to the gameplay area. So you think about that, then you think about, okay, what kind of a topography we will have, what do we want here, what kind of a biome variation it is, and then you just start sculpting, and then you just start placing one of the initial steps is to place the puzzles. Where do you want puzzles? How far between each other the puzzles will be? And then you just start sculpting have a preliminary like a foliage pass and landscape grass pass in it, you would definitely have a material setup previously, so you would have a visualization of your colors, and it'll be easier just to see how it works because the base material from Unreal is just it's a grid. It's not really that useful in visualizing what you want. And at that stage of development, you already have resources to visualize such stuff. You have textures. We use Megascans, so you can just pull them from the Megascans library, edit them to conform to our pipeline needs, and then just use them.
This is the one thing that I don't know and don't understand. If you have a scan for the texture for the landscape, right? So this is like a 2D image, right? So how do you conform it for your purposes? Like, what do you change?
You mean like a texture, like a grass texture or a dirt texture? You mean for that? Okay. I mean, we use Megascans as our reference, so what we change is generally the resolution for optimization purpose, because every texture comes as a 4K texture, and you don't really need a normal map to be 4K in that sense. You just put it to 2K if your color map is 4K, and then you would have other instances for like snow. Like does a snow texture that's white need to be 4K? I don't think so. So it goes like to 512 or something like that. I don't know. In that sense, the normal map is the king, I would say. But generally, the textures, the scanned textures themselves don't really take up uh, much work when it comes to modifying. If you take a now, if you take a like an other third-party asset pack that has textures, then those textures could have a different formatting of your roughness, metallic, displacement, whatever. Then you have to edit those manually, which like there's no standard of okay, the roughness goes into red, the metalness goes into green, and so on. Because you have sometimes you will have an occlusion mask, like ambient occlusion mask. Sometimes you won't. Sometimes you have displacement. Sometimes you won't. So it's a juggling work to make that work there. And much more goes into editing scanned meshes from Megascans rather than textures themselves. So yeah.
Yeah, and yeah, again, to be clear for the listeners that might not know this, if you generally speaking in rendering, in 3D rendering, you're using shaders, which is just like a GPU code for rendering, and at some point you apply colors to just 3D models, right? So in engines you wrap shaders that are included in a thing called the material, and in order not to tweak the generic shader code, you use the base material that accepts different kind of maps. And what you're saying, for example, roughness map or normal map, there are different 2D textures that you add to this material, and they influence how the surface is rendered, like how the colors are determined. Even though, for example, for the normal map, even though that you're rendering something that is in terms of like vertices, it's flat. You can make it look like it's not really flat with the different normal map and different normal vectors that will interact with the light. So mimic, for example, crevices on the wall or things like that. So, and this, as you mentioned, it's not standard, right? So depending on the rendering type and what are you doing in a shader, you can have like here's a roughness map, and now you switch to the so-called PBR workflow. So like physically based workflow. So you can have like a asset that you buy is not really related to the workflow that you have. Is Talos Principle based on this physically based rendering in terms of material?
Yeah, the Talos 2 uses your default, I would say, a unchanged Unreal Engine PBR shader. In terms of like, we have an underlying shader, then we use the material editor themselves, which is a higher level abstraction of the shader code. We don't really do HLSL in this sense. And HLSL is a shader code, a type of a shader code. There's also GLSL, and I don't really know much about that stuff, so I can't really talk about that. But then, as you said, we use a material which Unreal calls a master material, where you set up the node graph for different functionalities you want, and then you would have a material instance from that master that would then have the parameters that you set up. For example, base color, the color modification, well, the tint, the color tint, the color contrast, the normal intensity, the roughness modifier, etc., etc. One thing too, I would just reveal this for our other the future projects. We did a huge material refactor from Talos 2, where we don't use roughness anymore. Well, roughness textures. We still use roughness, but we generate roughness from base color, and all uh, in all cases so far, it's good enough. And when I say we generate from base color, we take the red channel of the base color and just tweak the how would you say that? We tweak the curve of that input. So we use two textures only. Yeah. And even for vegetation, so one of my colleagues made the refactor on the default master. I made the refactor on the vegetation master, where we also use two textures like base color and normal. But for, let's say, translucency, the subsurface scattering, it's mimicking how the sun goes through the leaves and how you get that nice smooth warm coloring on the leaves. We use base color for that because it's generally the same. We don't really care too much. So, okay, it's not maybe physically correct, but damn, it looks good, So let's use that. So we don't really have to have an extra texture for translucency. So we just use.
Yeah. So what you're saying is that because as you probably, yeah. So when you have big projects, you have shitload of materials, and you need to, the more work you need to do per material, the more actually work you'll need to do in the production of the game, which takes years. So when you're saying that you don't need, for example, now roughness map, you're saying that you cut, for example, 25% of work that you need to do for a material. Am I right? Like, this is what you're...
Yeah, you don't need to think about, okay, now I've got a random asset pack that has this standard of the texture formatting for your grayscale masks, so roughness, metallic, and so on. And now you just say, okay, they have so the unifying standard is they have base color and they have normal map. Everything else doesn't matter at this point. Now that we moved to this kind of workflow. Now, one thing to think about is we still need metallic maps because that's a binary mask where, like, this is metal, this is not. But we generally when we say we don't use roughness, we have a ability to use roughness masks, but we just don't by default. You can press a flag that says, okay, use roughness map, and then we just put a roughness map if you have, or use metallic map, then just put a metallic map if you have it. But generally, we only use two maps for all of our shaders right now.
Okay. That's like, from the production perspective, it's amazing. Because you can, all the saves you can get for these kinds of things, they speed up the production dramatically.
Yeah, the production is sped up, and you have less material complexity in a sense of performance. So you don't use a texture sampler, which is great. You don't get memory intake, which generally roughness maps and all those grayscales were never really too expensive, but still it counts, And it's just a general optimization of life when we don't have more maps to worry about.
How big your master materials are?
Big. Now currently the default mesh master was fairly big. We had a even bigger one that was like a multi-material that took like five materials, one base material and the other four materials for your RGBA mask. So red, green, blue alpha channel of the mask that you would use. Then we would have like additional mask for vertex colors from that would you could mask them by vertex colors themselves. That was a big shader. For our future projects, one of our colleagues did a huge refactor where we would use like a one default master using material layering system. So Unreal Engine has a material layer system where you would use. I'm not 100% in on it because he was doing it. I was doing some other stuff, but you would have a material layers where you can modularly add layers that would use your material layer node. I would say asset. It's similar to setting up your normal master, but instead of a master material, you would have a master material layer where you do all your functions and parameters. So when you add a layer in your material instance, uh, you would add a material layer master as a parent. So you would get your parameters, and then you add a material layer blend master that says how do you blend this layer with the background or this layer with other layers below. So it's a bit more complex system to like handle and to debug. I say that to debug for a person who didn't make it. It's not that hard. It's really cleanly done, and we care about like cleanliness.
What can be inside a layer? Because I can understand like you have a complex material with all the let's say effects that go into the material that is like a master material, and then you say another layer that blends with something. So what?
Okay, so in a sense, the layer now one layer is what default master material was before. So every functionality that was in the master material before, the default master material for our meshes, is now in the layer. So you can have, so we basically merged the multi-material and default masters into one with this material layering system. So by default, you just have a background, so a base layer, that's your M default, that's how we call it, M underscore default. And if you add more layers, you then have your modular multi-material, but multi-material master material, but it's all the same master. So it's like it's one permutation. It's not like multiple, and generally for uh, convenience of how do you say that of supporting it and just keeping it clean, or if you need to have changes, you just change it in one place in one material and not in like another material or a function. It's just there, and it's a very flexible and modular. But to understand it, to keep it clean, and to make it is a bit more complex than before. It's like a new system we're getting in.
Okay. So you, for example, have all the properties like you would have, generally speaking, in the master material, but get it, let's say, in the layer, you say, okay, the subscattering part here, we want that, and in the same like material somewhere else, you know that the subscattering part, you don't need that, so you can like don't include this in a layer, and it's still the same one. So if you modify it, modify for everything.
Yeah, pretty much, something similar like that. Yeah, one thing to know, in our default material, we don't use subsurface because the vegetation is a separate thing. Let's say for a tree, we would use two materials, so the default material for the bark and then the vegetation material for the leaves.
Yeah, so let's continue with our train of thought. So we were talking about creating a landscape, right, from the level, and we get to the material part. So and you were mentioning the textures, getting them, for example, in this case, Megascan, tweaking them, adjusting them to your needs. So then you have like a terrain that is textured, and the work for the terrain is done.
No. No. Next, you would, as you're doing the sculpting, as if someone else is doing the sculpting, you can still do like material work. You still need to define, okay, what will be in the landscape grass. That's the system they use for procedural scattering of different instances throughout per layer of the per painted layer, I would say, because there are different. It's a different terminology, and you would just you would tweak how those landscape grass types or assets would be distributed throughout the landscape. And as you're doing that, someone else would be like painting or sculpting the landscape, or after I did the landscape grass work, I would just go back to painting and sculpting the landscape. And it's just a general iterative work. If you want to add cliffs, you would add like meshes, and then you would manually uh, adjust the landscape for those cliffs, so you don't have any leaking landscape, or they would blend well with the landscape itself. So you just add that. I tried to make a Houdini tool for like adapting the terrain to the cliffs, but I never got it working because Houdini Engine wasn't really liking. Something didn't work with Houdini Engine and landscape itself, so it just kind of fell out. Didn't really have the nerves to do it because I'm not really very well versed in Houdini like some other colleagues of mine. So it was just a pet project of mine. And after that, you would it's just constant iterative work on the landscape as you get new changes in the puzzle position, new changes in the layout, new changes in. We even had a huge change, especially for East 3, alongside with it being like a bit smaller level, at least 50% smaller level. It was previously extremely forested, but due to the performance cost, so that one of my colleagues came in and just redid the whole like vegetation setup and added a much more cliffs, or well, rocks, huge rocks, as you could see, and just smaller patches of forest here and there, because well, foliage is the most expensive thing in Unreal currently.
Yeah, and in terms of foliage, how do you do that in Unreal?
In what sense? Because it's a very wide question.
So, what I'm saying is both in terms of like rendering. If you're rendering grass, right, you usually render plates of grass that are 2D, that are facing like billboard.
Well, no, not now, because we started doing that. But then as we merged onto Unreal Engine 5, and then as I learned a lot about how Nanite works and how it works with that, we started using like a Megascans grass that has each blade is its own mesh, I would say. Well, not the bundles of grass is one mesh, but each blade is not masked. We don't use masked grass because that's more expensive than having a opaque grass that has a bit more vertices, because Nanite is that powerful when it comes to handling the vertex number, the vertex amount, rather than handling masked materials because of the overdraw problem. Currently Nanite is most struggling with overdraw. The overdraw is the biggest cost component on Nanite. So we generally, for grass and flowers, we generally use either extremely well fitted masked meshes for flowers, or opaque meshes for grass. And for trees, we use masked planes for branches and for leaves.
I think you need to tell me a little bit more about how Nanite works, because I only know like a couple of things from the internet, that there's like you can have millions of triangles and that's it. Like,
Yeah. Well, you can have millions of triangles, but there's a lot of buts. So Nanite itself, as you can see on any Unreal marketing video or on their documentation or on their blog posts, it's a virtualized geometry. If someone is familiar with virtual textures, I would let me just quickly say like how virtual textures work in a higher level domain. What you see in a scene, what your camera sees, is what gets loaded onto the GPU memory. So let's say you see let's say, let me just, you see, this is like a texture, a 4K texture, let's say. It will get sliced into however many page tiles of 128 by 128 pixels. And now that's how your texture gets deconstructed. So if you see like a half of that texture on the screen, only half of those tiles, half of those texels, well, pixels, I would say. Texel is just a complication of it. How many of those pixels on the texture you see is how much memory you will need. Whether if it's a regular texture, you will see the whole. The whole texture will get loaded into the memory. So you basically, with virtual textures, you halved that texture cost, the memory cost, in that sense. Same goes for roughly the same goes for Nanite. So it's a virtualized geometry. And it gets bundled into clusters of 128 vertices, and all those clusters can be loaded into memory. If you see those clusters, they will be loaded into memory. If you don't see them, with a lot of asterisks, if you don't see them, it will not. It will get culled, and it will not be into memory. So you can have a per vertex culling. So it's per cluster culling. If you see a statue, the behind of that statue won't get loaded. You will not. It will be culled first of all, and it will not be in memory. So that's how Nanite works. Additionally, it works. Additionally, it is a per pixel LODing, level of detail. So a level of detail is the further you go from the mesh, the less resolution it will have. So this is automatic in Nanite, which is also great. That's how you can have a mesh of 4 million vertices, but in in scene, if it's really far away, you will see however many pixels that mesh resides in.
And Nanite does this like during the rendering
Yeah.
pipeline step, right? So it
So the clustering gets in on import, and the calling, the LODing is real time.
okay. That's nice.
Yeah.
Okay. And you're saying that you can render grass, for example, now more efficiently because
Yeah.
you can leverage this because you won't actually render all the triangles that you don't see anyway, which would be which is more effective than just doing like 2D textures that you would print, like render anyway, but then upload them with the other thing that is in front of them.
Yeah, if you're using nanite, mass materials is something that you would shy away from. So the plain grass is something not to. It would be even if it had like a 10% of the vertices, it would be more costly in performance. If you're doing a non-nanite workflow, then you would use all the old pipelines and the workflows you used before. So it's a whole new paradigm of work, how you do it.
And if we're talking about foliage, all the rocks and other things apart from grass, is this like then rendered in the same manner?
Yeah. So in Talos 2, 98% of meshes is nanite. And in our other projects, I think 100% that can be nanite will be nanite meshes. So for, let's say, like water and all like glass, so it's a translucent mesh, those can't be nanite yet. So everything that can be nanite, I always say, and in the documentation that I wrote for our team, I said everything that can be nanite should be nanite. So That's basically it.
Okay. That's another advantage of using an engine instead of doing things from scratch. Like I always like, like to ask guests, like, wouldn't it be easier for you to like write your own engine and just the features that you require instead of leveraging like these beasts? And like usually from what I see, it's like no.
Well, look, I think we in Croteam have a first-hand account of that. Until like Talos 2, we used our own serious engine that was an in-house engine, and you just don't have the amount of people who can properly support that. We were years before Unreal. We were even we were even behind Unity in some aspects. We only got proper PBR on Series M4. It was a game before Talos 2. So you can't really compete with a company that has a hundreds and hundreds of people working on specifically the engine and not on Fortnite. Fortnite is just a test bed for those features, I would say.
Yeah. Okay. Getting back to the landscape then. I think we didn't cover it. We didn't cover trees, right? Because that's not foliage. Foliage is grass.
So, grass, small rocks, that's landscape grass. I don't know. I don't know why it's a weird terminology. And a serious engine would call them crumbs. Even that is a weird. It's just I don't know how I would even call it, like landscape detail. So, but as I will keep to the Unreal Engine terminology. So landscape grass is a different system, whereas in Foliage, it's a differently rendered mesh. It's a instanced mesh. Well, a hierarchical instance mesh, which is a bit different than a pure instance mesh. When I say instance mesh, it's like you can have millions of meshes that are rendered once. You don't render for each instance, so it's like rendered once and on those within those transforms or like locations and rotations and scales. Um, so for foliage, used we primarily used a procedural foliage system of Unreal, and sometimes we manually painted those same foliage instances where we needed them specifically, that we needed to be authored. And in foliage, we used trees. We used small and big shrubbery, small trees, flowers. Now get this, we set up flowers through the foliage system since the procedural foliage has a much more of a natural clustering of flowers, whereas the landscape grass system is a more of a uniform scattering of instances. The procedural foliage system itself can get that clustering effect for flowers that we want. So it's not like a uniform spread of flowers or other bushes or other like grass crumbs that we get.
Okay. So trees, larger, medium-sized rocks or other things.
Yeah.
Flowers for the foliage system.
Yeah.
And so in terms of trees, for example, or flowers for that matter, if you provide a mesh and just a model and the textures and things like that, you hook it up in the foliage and you pretty much paint with the foliage the landscape. And then is there any complexity to it other than setting up the rules for the foliage and things like that?
No. The biggest part is setting up how it will grow. How do you grow the procedural foliage? You would assign each instance to a specific landscape layer, and then you would generate uh, the whole foliage.
Okay. Then I think we covered, right, the landscape part of the level.
Yeah.
Okay.
Yeah.
Okay.
And foliage, I would say.
Yeah. That's true. We got it included.
Yeah.
What about the water? And
Yeah, water is a tough beast. I did the water material, and I went through like three remakes, or I would call it refactors of the material itself. We first started. Well, I first tried out a newer how do you, a single layer water shader that the Unreal Engine has. I think it got in Unreal at like 4.26, 4.27, but just didn't fully work with the lighting that we wanted at the time. And at the time, I did a custom water shader that would just mimic uh, the light path through the water, the light absorption through the water, and it's not like physically based. There's a lot of like artistic there's a lot of need for artistic setup for it to look, and it's not the most user friendly. And I don't like how I made it, but it's like I had a lot of other stuff, so it's as much as it is a complex material. Uh, I'm not happiest about it. I'm not sure how I would make it better. My wish is to actually use the single layer water shader if it actually works. I haven't really tried it lately. I should probably. The single layer water is has does a much better job of presenting the proper colors of light going through the water itself. Uh, there was a mini outrage that we didn't have water ripples. I never had the time to implement it, so one of my colleagues post-release implemented it. So now we have water ripples. We are on parity with Talos water ripples when you move through them. Yeah. When in the 1.0 release of Talos 2, when you moved through the water, you didn't have any effect. So it's like, oh my God, ripple gate. But it was added later.
Okay. And what goes into water shaders? You want to mimic what would someone see looking outside of the water. There's also like the part that you look inside the water, in if you
And
fall
that
in
was
the water.
Yeah, that's handled through a post-process effect. You don't do you do it through a special shader that's applied to a post-process that's on the water level and below. That's a separate material. Well, when it comes to material of the water itself, water surface, I would say, I call it water body material, and it's generally in terms of the first term is the water color, so it's how transparent it is, how light goes through it. So what color it is, you can like change it to be red, even. You can have any color you can have there. It's generally like, for example, for more of a muddy water, you would have a brownish color. For more of a lagoon water, you would have that turquoise blue or aqua blue or whatever blue you think could best mimic the the beauty of the lagoon water itself. After that, but also within there comes the opacity of the shore, opacity, uh, how deep can you see in the water. Then you would have the caustics term. So we have like I think it's a four-way chaos. Uh, it's a special function in Unreal that's like takes the what's it called, the texture, the caustics texture, and samples it 4 times, and then just like scrambles it around and blends it somehow.
Or what does it mean? Caustics? I like.
Caustics. So you know those like when the sun hit. If you ever seen like in a water pool, when the sun hits the pool, the bottom, you see all those like lights, like how light goes through the water and gets refracted, and you see those like stripes that go. They're in the shape of ripples, but on the bottom. So we don't simulate that. It still can't really be simulated in real time as far as unless NVIDIA. I think NVIDIA can only do that in their demos. But we use a pre-made texture of caustics that just gets moved around and gets sampled 4 times and moves around randomly and gets blended. So it's just like an effect. Let me just.
See, that's what I'm always like amazed that I will tell that something doesn't look right,
Mhm.
but I wouldn't be able to even say why. Like, I
Yeah.
know that something in the real world looks differently,
Yeah.
and in this game it doesn't look like this, but then you can't even tell. And you need to not only tell, you need to know how it works, and how to mimic this behavior from real world into the engine.
Yeah.
This is impressive. This
Yeah.
is really nice.
Yeah, the crucial thing there is to try to split the problem into its components. Like sometimes when we get like feedback on our work from other colleagues, sometimes it's hard to say, okay, something doesn't look right, but it's maybe this, it's maybe that. I don't have the pinpoint to it. Most of the time we know what doesn't work, but sometimes we just something's not there. I'm not sure. Maybe it's this. Then you start guessing. It's a guessing game at that point. But the worst thing is when something looks right, then someone adds something, then okay, without that it doesn't look right anymore. So it's like you gotta pick your battle somehow.
Yeah. If you split the problem into components, like you said, then in the materials you can actually do like handle them one at a time, right?
Yeah, yeah, that's how I did it for water. Like other terms for water is like ripples, your wind ripples. I would say you would have like your ripples up close, then you would have ripples far away. Then later we added another like a modification to that term, where we would have if you ever like traveled to the seaside and you were on the mountain that looked over the sea, you would see like differently sized ripples. You see like it's it's striped. It's not the same ripple type everywhere. So we added that, I would say. Yeah. Like before that, we would have like a one type of ripple, one type of tiled ripple everywhere. But then later we added a mask that masks out 2 or 3 ripple tilings. So we would have a differently like in this part the wind is stronger and in this part the wind is weaker, something like that. That's the that's the that was the philosophy behind that adding. Then we would add a far away term for color. So when you're far away, you would see like a ocean bottom. That's basically a noise color for like green, blue, or dark blue. Just like you would see from a drone footage, you would see where the clear water is on the shore. You would see different shades of blue and dark blue. That's how we mimicked the ocean bottom on the far away distances.
Okay. Yeah, that makes sense. Like for the base color, you don't see ocean bottom, but it's far away because it's too deep, so you kind of see one color.
Yeah, you only yeah you only, yeah that only pertains to the shore, I would say. Yeah, we don't have waves. uh, we opted not to do waves because first we didn't have the time. Secondly, it probably would be too costly for us, and we didn't really have much time to learn how to not make it that costly. For our future project, we might have some. I did some research in Gerstner waves, like physical Gerstner waves that they had like 10 years ago in some games, but don't mind that. Uh, and with that, we would have a proper foam function because for now we only have a foam that's like it. I don't like the foam implementation I did for the Talos 2, but it had to have something, so it's whatever currently. But I would like to have like a physical like Gerstner waves through geometry. But it's an ongoing research that I'm not currently doing, but I will get back to again sometime.
Okay.
And for those like Gerstner waves, it's a function to make natural waves for water. It's used in Sea of Thieves, and I think it's used in Arkham Knight series. Um I think it's even used in the latest. Well, it's probably used in the latest Skull and Bones game. It's used in all Assassin's Creed Black Flag and Assassin's Creed 3 games and stuff like that.
Yeah, where there's a heavy emphasis in like pretty much all the game happens.
Yeah.
Yeah. For us, the the argument was it's just water. We're not on waste. It's just the priority wasn't there to make it like okay, we need to work on a proper water shader for like 2 months to make it like realistic. I would say it's just okay, make it pretty, just that.
Make it pretty.
Yeah.
Make it realistic. Make it pretty.
Yeah.
And what about light in general for the
Oh, yeah.
levels? Like how do you, first of all, like how do you conceptualize work on light, right? Because you can make a level. You have a terrain, you have a foliage, you have like trees, everything, and then like even when you have a water surface shader, you have light going through that, but then you tweak, for example, the color of the light.
Mhm.
And what I'm trying to say is that at what at what stage of the process do you think about light for the...
From the very beginning. From the very beginning of the level itself, the lighting should be. Oh, it wasn't at the beginning of Talos 2 development because we didn't really have a dedicated lighting artist. I became a dedicated lighting artist later because I was really enthusiastic about Lumen and generally lighting. So yeah, I really enjoy lighting stuff up. And but generally, you would want to envision what type of lighting you want for a level in the very beginning as someone is doing the landscapes, the mechanics, the level layout, level design. You should think about lighting and maybe even get a first production lighting pass on it if you know what you're doing and what you want from it. So for Talos 2 we tried to first we tried to make it pre-baked when we were in uh, Unreal Engine 4, but the I will be honest here. Unreal Engine's pre-baked lighting is it's a it's a real pain to make it work, and it generally doesn't work properly. There's a lot of artifacts everywhere, even with CPU baking and GPU baking. It's not good, and that's one of the bigger reasons why we decided to migrate to Unreal Engine 5 because of Lumen. Lumen was very optimal even later. It was more optimized even later through 5.1, 5.2 updates. And Lumen is a dynamic global illumination system.
Yeah. So when you're saying pre-baking, you mean that all the light, you cast light and then you save what the color of the texture is?
Yeah. So pre-baking is when you generate light maps and shadow maps. So light maps is how the GI will be applied to all the meshes. It's a separate. It will be baked in separate textures. And shadow maps is how shadows are casted on objects, which will also be separate in baked in a separate texture. And that itself has its cost. It's generally really optimized for GPUs. The GPUs won't. It's not heavy. It's not dynamic. It's once and you're done. It has its own memory costs. Well, huge memory costs. It's if your levels are big like our were at the time, and the baking itself took ages. It really took a long time. Well, GPU baking was faster, but still had a lot of artifacts that were unacceptable for our wishes of quality, I would say. So we opted for Unreal Engine 5. We definitely said, okay, we'll definitely use Lumen, which is a dynamic lighting system that has dynamic global illumination, and and our shadows were also dynamic by after that. And uh,
Does it? So what's the breakthrough here with the optimization? Because like you could have done dynamic lighting without baking anything, like since day one, right? But Lumen
Yeah.
comes and there's some sort of optimization underneath.
Well, previously the dynamic lighting for Unreal was very ugly. Was very, very ugly. Non-lumen light. We have a non-lumen lighting solution for lower configurations in Unreal, but we did some tricks to actually make it prettier, I would say. And there are two actors that we customly made. First one was lumen adjusted lighting. That means that you will have a separate skylight color for lumen and separate skylight color when lumen is disabled. That also pertains to skylight intensity. So you have separate skylight intensity for lumen and non-lumen setup. Second, so let me just get back to it. The sky that was used because, for example, when lumen is off, uh, you will get most of the time you'll get your classic like blue coloring on every shadow there is because of the sky. Sky is blue, but in reality you would get your landscape color most of the time in shadows or whatever your bottom surface is on the unless it's an open field, then yeah, it works fairly well. The non-lumen skylight by default works fairly well on meadows or any other open area, but we generally don't have much of those in a sense of we have a lot of canyons, we have a lot of uh, fractaled landscape, I would say, and for that, we would definitely tweak the skylight color and skylight intensity. Sometimes the intensity would be too much, so we wanted a darker skylight for non-lumen. So that's what comes in that term. Secondly, we would have a second actor that's fully custom is a skylight fade volume. So that is a basically a brush volume that when you enter it and you are non-lumen setup, it does nothing in lumen setups. And when you are in non-lumen configuration, when you enter, the skylight color would change. So, for example, that was heavily used when you transition into interiors of the level. For example, Lost Labs in Talos 2. When you enter, the skylight would come from, let's say, a white color to a dark brown color, and that's how you get your dynamic. Like, okay, it almost looks like lumen. It's not exactly because you lose your GI, you lose your color bleeding from lights from other surfaces to the next, and you lose your ambient occlusion. But you don't get if you didn't do those changes, if you don't have uh, that actor, the interiors would be extremely bright and all in blue, like your blue coloration because of the sky. There's no skylight occlusion. That's what I want to say. And with that actor, we dynamically in runtime change the color of skylight to what we want it to be.
Okay. So if I am just on the edge but inside the Lost Labs and I look at the sky from outside,
Mhm.
would I notice the difference?
Well, this so I think the skylight itself is just a light caster. The sky itself is controlled by the sky dome, the HDRI image, but the skylight just casts the light onto other mediums, onto fog, onto meshes, and so on. Um, One problem we wanted to avoid, something that was in the beginning, when you actually rotate towards the exit, we would have a we so that setup was made in two, I would say, two volumes. The first volume would be the transition volume, and the second one would be like a full-on volume where the skylight is always wherever you look is darker color. But when you're in the transition volume, when you would turn around to the exit, the skylight would dynamically change back to its original form, to its original color. So we had that handled. We tried to handle all the edge cases that we could. We generally succeeded. The user experience is not that amazing. When you get the grip of it, it's okay. Not the fastest workflow, but it's good for what it does. And I think it's one of the most powerful things that we managed to do to make non-lumen lighting look okay in comparison to lumen lighting. And lumen lighting just by itself does incredibly well.
Okay. So you have places where you switch from the global illumination coming from lumen with the blue shadowy tinted blue tinted shadows
Yeah.
into different places, like especially interiors like Lost Labs, and you
Mhm.
change and you do more than one. Yeah, the attention to detail in these kinds of things, it's incredible, because like you can see again when I was entering the Lost Labs, I can
Mhm.
feel obviously the difference. Like there's something, some tweaks for the lighting. It would look differently, but I wouldn't be
Mhm.
able to tell. And
Yeah.
I would guess, just like you said now, if I just stop in the right place and I look differently,
Mhm.
you need to handle a lot of edge cases for this, right?
Yeah. I mean, we definitely thought about, okay, this will probably be a problem if you are like rotating and you would see the outside shadows be extremely dark. Okay, we don't really want that. So when you're turning around, we will want the skylight to go up again to the exterior state, I would say. When you're in the exterior, that's the state of the skylight we want when you're looking outside. When you turn around back, we will want to have the Lost Labs skylight state. So it's just that, like, okay, we have the foresight to handle that, but it's not the most complicated system, but it's really useful for that kind of thing. If you want to keep your lumen and non-lumen not that egregiously far apart.
And for the lumen part, so like you just set up lumen and then it works because it's somewhat underneath effective, and like now
Yeah.
like you can
Yeah.
handle it, or
Yeah, the lumen itself is just it's really magical, I would say. One thing to keep in mind is for lumen there's another different paradigm of the way you construct levels. So because Lumen uses different systems in Unreal that already existed, so the biggest thing is distance field. Uh, Now distance field itself is like a 3D volumetric. It's a 3D texture that's generated for each mesh that represents the volume of a mesh, something like that. It's a it's a volume represented through a 3D texture, and every mesh can. Generally, every mesh generates distance fields. And distance fields are used in Lumen are used for ray tracing, because Lumen itself is ray tracing. Um, we specifically used software ray tracing only in Unreal, in Talos 2. So the tracing goes against the distance field, and the color is gained from something called the surface cache. And the surface cache is a collection of planes that are generated for each mesh that project the texture of the mesh to the plane itself. So the planes are like a even more reduced representation of the mesh for the ray tracing scene. So taking all that into account, the difference in level building is that you would want a modular style of level design. In a sense, if you are making a structure, you want to have your walls modular or as least complex as possible. We did take our liberties, and our puzzles are fairly complex in its shape, and it generally works well with with Lumen. Sorry. Uh, but if you would look into like examples that that Epic gave us, if you would have like a whole room, a whole house as one mesh, that would work extremely bad with Lumen. So it's generally about a different setup for the meshes itself. You will want a more modular meshes, more fractaled, or more fractured meshes, rather than one huge monolithic mesh that wouldn't work well with the distance fields. That wouldn't work well with surface cache because it's just limited. Now you have a different. Now you we also for our next projects will handle the hardware ray tracing lumen. That also takes some different approach. That can work well with like monumental monolith meshes, but it's okay. It works well with the software ray tracing lumen. Just you have to take different things into account for hardware ray tracing.
Okay, it then starts to make sense in my head. Like, because if you had just global illumination and without the surface cache and without like 3D textures and volumes wrapping that,
Mhm.
every trace needs to have like a custom angle projection and deflects in a different way, and you have to do a lot of weird math for
Yeah.
those. And if you have like a standardized volumes that are blocking, you probably can do a lot of optimization.
Yeah.
So
Yeah.
it's
I don't know the exact math and the exact code, but it's generally a much more optimized way to work within software. Hardware ray tracing does it against real triangles, but it's generally again does it against a simplified mesh. So for Nanite, generally when you use Nanite, Nanite generates a fallback mesh, so-called fallback mesh. That's a regular mesh, non-Nanite regular mesh, but extremely uh, toned down in its resolution. So it's generally optimal. But hardware ray tracing itself is it takes um, similar I would say pipeline steps and pipeline aspects like any other hardware ray trace real-time hardware ray tracing system.
okay. Okay, and for the lighting part, if we combine lighting and water surface shader, do you rely on Lumen casting light
No.
on the water?
No.
You just turn them off.
The only thing that Lumen does is reflections in for water. The light itself is just how it's determined. The passage of light is determined inside the material, so it's not like it's not physically based. It's just artistically derived.
Okay, okay, okay. And for the skies, you mentioned that this is the 3D texture that wraps the whole level.
No. For the skies, we initially wanted it to be dynamic with volumetric clouds, but that fell off rather late in development because the volumetric clouds we couldn't get them to perform well, and they didn't look that great generally. So we opted for static HDRI skies wrapped on a sky dome, not a sky sphere, but a sky dome. And those textures were 8K by 2K, HDR compressed. So I think each of them were like 24 megabytes of memory intake. So that was not too much. And they looked great, and they were very helpful in creating a custom lighting mood that I wanted for each level to have.
Can you say that again? I did not make the link.
So the HDRI skies are more easily customizable in our direction than, let's say, physically based sky atmosphere actor that Unreal Engine gets. So the sky atmosphere actor, like physically correctly simulates the atmosphere, how the light comes through the atmosphere. But we generally, that when we transition into the HDRI skies, we I had a much more freedom and ease of tweaking how I want the light to look in a level.
Okay, okay. When you say tweaking the light, what kind of properties do you mean?
Uh, it damn. Okay, give me an hour. Okay, so I generally tweak um, when I get the base light set up that I want. I would tweak generally the color grading in the post processing. So one thing I might change is the temperature of the sun. I don't change the color. Color is always white, but the temperature can be generally I go towards more warmer colors because if your sun is lower on the horizon, it's more warmer. Generally, it's not hotter. I mean, it's not colder in a sense. It's not bluish. It's more orange, more yellowish, I would say. Um, that's something that I might change depending if okay, this maybe I need this scene might need a bit more warmth through the sun itself, not through a warmth color grading uh, parameter. If I set up the lighting itself, I would set up the fog. I would set up the HDR sky how I want. Then I would just set up the how bright that sky would be. How bright I want. I recently added a contrast control for the skies. Sometimes the skies are just too like bland. I would say I just need to I just need a bit more contrast, a bit more like oomph in them, and then it's all just in the post process after that. How exposure works, set up your local exposure, set up your color grading, set up your bloom, how you want to how you want your bloom to be strong. Um we have set up the tone mapper if you need to, and generally the most tweaking is in the post process after the fact that you set up your base lighting.
Yeah, and just to mention this, that post-process effects are the ones that are applied like when you have already a frame and you treat this as a 2D kind of like a photo, and you change as a photographer would do in the editing of the.
Yeah, imagine you take a picture, then you go to Lightroom or Photoshop, wherever you wherever you color grade your photos. That's what post-process volume does in Unreal Engine. It's not as it might not be as as detailed as Lightroom because of it's real time, it's per pixel real time processing, but it's really strong if you know how to use it.
Yeah, and it's funny in games that you can have like volumes, so just places, and you can switch in the same level, you can switch and move to different kind of boxes, and here I am, and this is already like an evening, and I go here, and now it's a morning, right? And you can swip between them.
It's pretty cool. The funniest I find the transitions in Dark Souls, the first one, I find the funniest. When you like go through the door, it goes from like a bright contrasty post process to like gloomy green poisonous atmosphere. Like, well, this was erratic. It's funny.
A lot of I wonder like how do you now see the world, like because you have to have such a detailed vision for all these things. Like I wouldn't, I would be probably locked or scared shitless because there's a monster in Dark Souls, and just like just make sure that I'm not gonna be dead in the next couple of seconds. And you're like, what a transition of colors. Like
It's funny because I generally find myself in awe of what people do in games. Like lately, I've been playing Helldivers 2, the newly released game. I thought it was made in Unreal because it's really, really pretty and really detailed, but it's made in Stingray engine, in heavily modified Stingray engine. It's amazing. Like praise be to them, whoever made that game. But generally, I just in that type of game, you enter a game, you see the big picture. I generally train myself to see the big picture. Like first off, okay, this is beautiful. It's pretty cool. I like how everything works here. If you do look closely, which I generally avoid when I play, you see some defects here and there, but it's generally the things that like are not really important for the big picture. Let's say in Witcher 3, when I played that game like ages ago, there's a lot of like you see a lot of exposed UV seams. You see a lot of clipping, everything here and there. The hair is clipping everywhere. When you go into details, you see, okay, this game it may not be like kosher, whatever, but the big picture is this game is amazing and it looks great. You get immersed in it. It's like I don't care that there's a seam. Who gives a shit? I'm sorry for my language, but I don't care. Like no one should really care about that.
yeah, I'm Polish, so when you brought up Witcher 3 as an example, I'm already like, oh my god, it's gonna ruin it.
But generally, The Witcher. I mean, when you look into the crevices of any game, you will find bad stuff.
Yeah,
Mm.
I didn't play too much of Red Dead Redemption 2. I think that's one of the prettiest games there is currently.
Okay.
But you will probably find some not so professionally done or not so polished stuff. But who cares? The big picture is there.
Do you need a lot of effort to stick to the big picture when you're playing a game? Or it is it
No, if I play just for fun, not really. Uh, I've been doing this for 8 years. You get, at least I found myself enjoying games and not too much looking into details unless I'm researching for some stuff. Then I just go and okay, zoom in. Okay, well, how did they do it? Then I just pick apart how could they make this shader? What's there? Is that a detail normal map? Is that what? Is that? Like, I did that for Red Dead Redemption 2 when I looked into their water, which is pretty cool. But otherwise, when I'm just playing for fun, I don't really go into. I don't have that professional deformation or how they call it. I don't have that for that. I have that for real life. I have that for real life. There was a case when we were going to Dubrovnik, and we had to pass like a Velebit, the biggest mountain range in Croatia. Then we were going back from Dubrovnik to Zagreb to home, and when you look onto that mountain, you see a lot of thin, tall rocks, and we're looking at it, how is that real? If I made that in game, my lead would come and say that's ugly, that's unrealistic. Like, what the hell is that? Nature, what the hell? Like, sometimes nature really catches you off guard.
okay? Okay. I would presume that you see the most beautiful aspects and like, ooh, I want to reproduce that. But not
Oh
the
yeah.
not but the nature making ugly shit that's interesting.
Nature, it's not as ugly. It's like, how would that work? Is that realistic? Doesn't make sense. How did that come from? Why is that stone structure so big and so thin? I mean, so tall and so thin. Like, huh? How? Yeah. Who put that there?
Okay. What lessons have you learned on working on the environmental principle? Like, if you were
On
to
environment.
pass on some
Oh boy.
wisdom quotes.
I would say treat your third-party folder very carefully. Do not put anything. Do not put just anything in there. Keep control of the number of your master materials to a minimum. Um, yeah, start if you're a lighting artist. Start immediately as the level is being like made and the first structures are being made and put in there. Start your lighting pass immediately, just for a base. Just make the base of it, the base lighting pass. Um, read the documentation. That's what I would give. Like, read a lot of documentations. If you're an Unreal dev and you have the access to the Unreal development network, let's say a premium forum where you have where you can contact and um, report problems directly to developers, Epic developers, and just go there and if you have a problem, try and find that problem on that forum. Most of the time, you might find it, and you might get your answer how to fix it, or if it's been fixed in the next version, and so on. It's a Just try and look for as much information as you can get. But that's how I managed to get a lot of these. Like, I became a lighting artist, I became a technical content designer, technical artist, because I really go out of my way to. I have like a 20, 30 documentation tabs of different uh, systems that I may use or that I want to experiment with. Just experiment with stuff. If you're a level artist, uh, watch out what you're using, what type of content you're using. Not if your studio is not so organized in a sense of assets, be careful what you're using. Because sometimes you might have a lot of when you just search for a name of an asset, you might stumble upon an asset that's not maybe processed to be game ready or just won't be used. So be careful about that. Constant communication is very much needed, especially when you are moving on to Unreal from another engine. And when it comes to, I would say, visual aspects, Google Images is also your friend, where you find a lot of inspiration there. And another one of maybe the biggest thing, I would say, hyperrealism over photorealism. Now, photorealism is what everybody talks about. Is like, yeah, your realistic light interactions with materials, physically based rendering, this and that. Generally, it comes out to be very boring. When I go find the moon, I always do exaggerated renderings, exaggerated scenes in a sense of, yeah, I will start with photorealism, like physically based lighting values. Yeah, my sun is 65,000 lux in that angle. Okay, I'll set it up roughly like that. I'll set up the temperature color for the sun like that when it's on that angle on the horizon. But then I go in my post processing and I tweak the contrast of the midtone of color grading, and I do all that stuff to actually make it come out a bit more. I like it to make it how one of my colleagues says, fantastical, a bit more fantasy like. But generally, I want to create a certain mood in a certain level with light and post processing. That's why I always go to hyper realism, where it's like exaggerated realism. I think that's always better than photorealism, even in realistic games. For example, do you know the game Squad?
Game Squad. No.
Yeah.
It's a military simulation first-person shooter. It uses Unreal. It's photorealistic, but it's really bland. Okay, it might be immersive, but do maybe add a bit more mood to it, you know? Even Escape from Tarkov is not photorealistic, it's very hyper-realistic in its lighting. That's why it's so characteristic. That's why I wanted to achieve with Talos Principle too. I wanted to be, okay, it's a philosophical puzzler. Let's make it a bit more oomphy when it comes to mood. Let's make it fantastical a bit.
Make it fantastical.
Yeah.
Maybe I put it as a title.
Yeah.
Thank you so much. Thank you so much, Tomislav, for the talk.
Thank you.
Thank you for reminding me here. It's a blast.
It was amazing to learn all this stuff, all these cool things. Thank you so much. Take care.
Thank you.